Good day, everyone. Firstly, I'd like to thank the organisers for inviting me to make this presentation at this important meeting. I'll be talking about transport infrastructure adaptation for a changing climate. As an engineer, I'll be looking obviously more at the road side than the freight side, but I'll try and bring the two together as best I can. By way of background, a few points we'd like to just introduce. Obviously, the freight industry is 100% dependent on a good road infrastructure and road network. The economic viability and sustainability of the industry is therefore strongly affected by the road surface condition and the need for all-weather possibility. Projected climate changes will introduce greater impacts on the road network in most countries, even more so in developing areas. And I will be concentrating on developing areas as this was specifically requested of me. It's essential that roads are designed and, most importantly, maintained to minimize disruption from these climatic effects, particularly more extreme precipitation events. We'll look at some of the effects of projected climate change on the condition and possibility of roads and the impact on freight movement. Okay, what are the projected climate changes? Modeling climate parameters have been carried out widely internationally. It varies from country to country, but in general, the main effects we can expect are increased temperatures for longer periods, more severe and intense precipitation events, longer dry periods between precipitation events, more windy conditions with much higher wind speeds, and sea level rise affecting some countries. These could all affect road conditions and possibility. What are the climate-related impacts on roads? We'll highlight the potential problems and the impact on the freight industry. The following projected extreme events are of most interest to us here. The more frequent and severe extreme precipitation events and the more prolonged periods of high temperatures and windier conditions. The impacts of the extreme events on roads vary. Obviously, in the simplest case, we get temporary impassability, excessive wear of the road, and these end up in transport delay costs. We get damage to the road surface, ends up with higher vehicle operating costs, much slower travel, and more time delays. And then the worst scenario, total collapse of roads or bridges, where we get long delays or use of less desirable alternative routes. And we'll discuss this in a bit more detail shortly. We can implement adaptation measures. This is done by the road authority before the event, and this will reduce the effects of these problems significantly. But it's costly, and the sort of retro fitting of bridges, for instance, and retro repair of roads is just not going to happen to all the important roads that we'll be looking at. Okay, if we look at temporary impassability and excessive wear, extreme storm events affect unpaved, which are either earth or gravel, but we call them gravel roads generally, far more than paved roads. Obviously, the gravel roads have a natural gravel or earth wearing surface directly exposed to the vehicles and the environment, whereas paved roads, the pavement structure is protected by either bituminous or concrete surfacing. The kind of damage we get is surface erosion when water flows down the road, loss of material from the roads, ends up in erosion channels and things which affect the riding quality and ultimately the vehicle operating cost. Loss of gravel exposing weak underlying layers. As this erosion removes more material, we start exposing the underlying natural material layers which don't have the same strength as the gravel layer, and we start getting deep deformation, potholing, and deterioration. Deterioration of the riding surface, again just water accumulating on the surface, sitting on the surface, softens the road, we start getting potholes and deformation, which affects our passability if it becomes too extreme, and we'll see a couple of slides illustrating that shortly. And then obviously all the material that's eroded away and the gravel that is lost ends up in drains and culverts, and they end up blocking these important drainage structures. We need to get that water away from the road, the pavement structure itself, and lack of maintenance really ends up deteriorating the whole road condition. So problems are generally reduced by good design, good material selection and construction, and then, as you'll hear over and over, good maintenance. If we don't maintain the roads properly, then we have major problems. This is a typical road here where the drainage is not very good, water's ponded in the road, serious deterioration, large deformations and depressions, really affecting the speed on which you can travel on the road. During wet weather, one has to slow down significantly to navigate your way around these big deteriorated areas. A similar sort of problem, but this is really possibility now. The road has become extremely slick and slippery, and only four-wheel drive vehicles, in fact, could get by on this road. Again, just another example of a deteriorated road. The water's ponding there, softening the material, deep depressions are forming. One can see in the top left photograph, the vehicle's going right up into the edge of the verge, into the vegetation almost, to get around the damaged area. This certainly affects the speed with which you can travel on the road, as well as the condition or roughness of the road. On the other hand, if you look at the bottom right picture, This is a well-designed, well-constructed, good materials, well-shaped road. This would be resilient to almost any storm. And this is what the ultimate good unpaved road should look like. So paved roads are not spared from the effects of climate. Potholing, deformation, we see that in paved roads as well, ending up in increased roughness and increased road user costs. Ultimately, the cracking and deformation leads to the loss of surfacing, with potentially temporary impassability or total collapse of the road. Problems can also be reduced by good design, good construction, and good maintenance, but this is a road authority obligation, and there's not much the freight operators can do about this. We can see again the photographs on the right. Water's got underneath the surfacing, lifted it up, and basically it's just moving away from the road. The even worse situation is shown in the bottom photograph, where water got again into the support structure of the road, and the entire road for many kilometers collapsed, as you can see in this example. So the damage to roads and structures caused by flooding is an important issue that is going to increase in future. It's not always too difficult to repair, maybe 1 or 2 or 3 days to restore possibility, but then the road still has to be graded to smooth it out, improve the riding quality. Nothing can be done before the water has receded. So again, there could be delays. The road needs to dry out totally, or the water needs to get away totally, and the road needs to dry out to the extent that one can actually carry out repairs. The problem with heavy loads on saturated roads is we get premature failure. We get what we call poor water pressures developing in the material under the vehicle tires, and the strength diminishes to almost nothing, and we get shear failures and major distress in these layers. We'll discuss this a little bit later as well. Again, a low water crossing, we'll talk about these a little bit later, common in developing areas, which are designed to be flooded, but they can cause major delays. Cars cannot get through usually, and the cars block the road, interfering with passage of heavier vehicles. Landslides too are also often the cause of road closures. They're usually triggered by high rainfall, and they can close the road from a few hours to many months. You can see the upper picture here, it's a relatively small landslide, covering about half of the road, so it's still possible. The bottom photograph, this is a very large landslide, continuously moving. The road is actually buried under the debris at the bottom of the landslide, and there's a earth road deviation avoiding this landslide. Again, in wet weather, causing major delays. Impassability. We've been talking about temporary impassability. In most cases, these roads can be opened relatively quickly. Obviously, major flooding causes severe damage to bridges and bridge approaches. And we can see the upper photograph, the entire bridge approach has been washed away. And this same bridge is shown in the lower photograph. And one can see the second pier from the right has actually collapsed, and there's a sag in the bridge deck. This entire bridge had to be demolished and rebuilt solely due to flooding, and the flood waters got up to the bridge deck basically. This one, often this type of damage can take years to repair or rebuild. In this case, as I said, the entire bridge had to be demolished and rebuilt, and with the contractual and procurement and all the other issues, this took well over 10 years before it was completed. Okay, we've spoken about precipitation. Now what about high temperatures? We can expect longer periods of hotter weather in future. I think almost every climate model shows that they're going to be between these severe or more severe extreme precipitation events. They're going to be longer, hotter, drier periods. They're going to affect both unpaved and paved roads. Unpaved roads, we end up with more dust, more corrugations, the riding quality deteriorates, the safety deteriorates with the dust, the wear and tear on the vehicle components increases, the more dust there is, the driver and passenger comfort deteriorates. So there are a whole lot of extraneous sort of connotations related to these dry areas or dry periods in developing areas. Bituminous surfacing in asphalt. Bitumen is what we call a thermoviscoplastic material. So it's hard and brittle when it's cold, and it's soft and ductile or can flow when it's hot. And roads are designed to take these two extremes into account and to operate in the area between the extremes, so they don't deform, but they also don't crack. Okay, just to highlight the dust, we can see a bus here on a typical rural dusty road. Obviously for passengers in the bus, this is a significant problem. Most of this type of bus does not have air conditioning, the windows don't close properly, so it's very uncomfortable for passengers. If we look at the other extreme on a paved road, we can see the vehicle tracks left in the asphalt here. due to vehicles moving during very high temperatures and actual deformation of the asphalt. Again, this is a design problem. There's not much freight operators can do about it. We'll talk about that a little bit as we go further through this presentation. It's interesting to see the effects of direct sun and shade. These two photographs are taken just a few meters apart. The photograph on the left shows a pavement structure badly deformed. You can see there's a rut beneath that straight edge of about 30 millimeters. There's cracking, there's movement of material from beneath the surfacing that we call pumping. There's spalling of the cracks, which are slowly developing into potholes. Just a few meters away, in the shade of a bridge, that same pavement structure with the same environment or same rainfall and everything else, same traffic, shows absolutely no distress at all. And it's difficult to understand, but if we look at temperatures, we can put things into perspective. This is a plot of some temperature measurements taken in the western parts of South Africa. And there's three measurements here. There's the blue lines, which are the air temperatures, the pink lines, which are almost the surface temperatures of the road, measured at 20 millimeters below the actual riding surface, and the red lines are the temperature at a depth of 200 millimeters. You can see the blue lines show a typical daily range of round about maximum of 47, 48, perhaps up to 50 degrees, and a minimum down to about -6 degrees in winter. The pink lines, which are 20 millimeters from surface, and these temperature measurements are made every half a minute continuously for this entire period. You can see the pink lines vary from about 6 or 7 degrees minimum up to close to 60 degrees in summer. But even at a depth of 200 millimeters, the temperature fluctuates between around about 10 degrees and 45 or so degrees. So these temperatures are much more exaggerated in the road structure than we measure at the road surface. Okay, so let's summarize the effects of climate on roads. The results of climate-related damage are what we're going to have to deal with in the future. The best case scenario is increased vehicle operating costs. In other words, the roads are going to get rougher quicker. The worst case scenario is total road closure. We have long delays. We may have to use alternative routes even while the roads are repaired or rebuilt, bridges are replaced. These aren't always available, in which case it's a significant problem. There's no alternative route. They're not always in good condition, alternative routes. They're usually much lower quality, lower standard than the routes normally used. And with the sudden impact of more heavy vehicles on them, they deteriorate much quicker. And often they may be significantly longer as well. So the travel time has increased significantly. Okay, so what are the implications for developing countries? And I was asked specifically to discuss developing countries. Internationally, we've got about 64 million kilometers of road. In the Northern Hemisphere, 60 to 100% of these roads are typically paved and sort of 0 to 40% unpaved. In the developing world, if you look at the map below, you can see generally less than 20% of roads are actually paved in the developing world, particularly sub-Saharan Africa. And this is the biggest challenge in this part of the world, the maintenance challenges. So these are unpaved gravel roads. They deteriorate much quicker than paved roads. They need a lot more grader maintenance, re-graveling, ad hoc repairs after storms and things like that compared to a paved road. And in most countries, the funding for this is not available, so the maintenance becomes a significant challenge. Unpaved roads usually also have lower standard bridges and water crossings. As I showed you earlier, we don't normally put a high quality bridge on a low volume trafficked road. So flooding, the bridges are designed to be overtopped, closed for a short period, but in future these periods may become longer and longer, and so this more prone to flooding is going to become a potential problem on these roads in rural developing areas in future. More rural low volume roads with few alternative routes are found in developing areas. So most of these are unpaved. They have higher roughnesses immediately. Obviously your vehicle operating costs increase because of the reduced maintenance. And we'll look at the impact on vehicle operating costs in a couple of slides' time. They're more severely impacted by heavy vehicles during wet periods. And this photograph on the right shows typical tracks left on basically a saturated, unpaved road after 5 or 6 heavy vehicles have gone through. Obviously, when the water evaporates and the road dries out, it's cut up very badly. The riding quality is poor and trafficability, although you can get through in most vehicles, is can be quite a challenge. Often, as I mentioned before, they're low-level water crossings, small bridges, subjected to periodic inundation and transport delays. For cars and small light vehicles in rural developing areas, this is not a serious problem, but obviously if we've got large trucks carrying certain Freight loads, particularly perishable things, flowers, fruit, things like that, delays can be highly significant. Inundation or overtopping, however, is much better than total washaways. Inundation, we just have to wait for the water to recede. Washaways, the whole area has to be reconstructed. So engineers need to design for this, and in most cases they do. Just an example of the bridge designed for inundation. Okay, the marker concrete pillars along the bridge show the depth of the water. In future, obviously, if the water increases significantly in height, these could be underwater. That becomes a challenge because vehicles don't know how deep the water is, again, which causes more delays and has other implications. Okay, what's the biggest challenge in the developing countries? Funding. Most road construction, maintenance, rehabilitation depends on donor funding or loans. And these tend to be intermittent and unreliable, depending on the economic or financial state of the country at the time. So maintenance without a lack of finance, or with a lack of finance, often a lack of good equipment and often lack of good skills is a major problem. We often get poor construction and poor material operations in these rural areas as well. So, and they're in remote, challenging topography and often with very poor soil conditions. So low traffic volumes are normally carried on these roads, but many of these can be overloaded. And there's nothing worse on a low volume road than applying repeated overloads. They are not designed for this. They will fail almost immediately. So how will freight transport need to adapt? So I'm not a freight transport expert, but just looking at what I've seen over the years and the way forward, I think the main adaptations must be done by the road authorities. The road resilience, the road quality, the road maintenance is a function of the road authorities. There's very little the freight industry can do. We'll talk about this in the last statement on this slide. We need to make the roads more resilient to extreme climatic effects. So these future extreme storms and things have less of an impact on the road and less of an impact on the traffic using that road. This is unlikely due to the cost. To make a road, existing road, more resilient costs quite a lot of money, it takes a lot of time, and a lot of input is required, which is just not available currently in most countries. During upgrading of roads and new construction or reconstruction, it's important that road authorities build climate resilience into these pavement designs. And I think there's enough knowledge and experience around now for this to actually happen. So how can the freight industry help? Possibly with lobby groups, political pressure, direct funding, different designs, things like air suspensions perhaps, or sticking to dual wheels instead of single wheels, this type of thing. Also, don't overload vehicles. Apart from the damage to the vehicle, there's much more significant damage to the road. Don't use excessive tire pressures. They increase the contact pressure on the road, which creates more damage. And don't speed. This photograph below is a good indication. If one looks carefully at the top of the road, there is no damage at all. The bottom half shows a lot of corrugations. The difference is this was a minor access road. The vehicles moving left to right here on the top side of the road were loaded and traveling slowly. The vehicles coming back in the opposite direction from right to left on the bottom side of the photograph, you can see the corrugations. They were empty, they were going much quicker, and they were bouncing, causing deterioration of the road. We know roughness affects vehicle operating costs, and this is a typical example. Don't worry about the units. It could be rupees or rubles or rand or whatever. But we can see as the IRI, the International Roughness Index, or the road roughness increases, the increase in vehicle operating costs. And the upper line is for heavy vehicles. So we can see a significant increase with a not particularly serious increase in road roughness. We can go up to 14, 15 on many of these roads. And we can imagine what happens to that increase in vehicle operating costs. In some trucks on a saturated road affect the pavement structure, I said before, the poor water pressures. In some countries, trucks are banned from roads for some time after flooding, even to avoid this. It's similar to the cold northern hemisphere restrictions during the frost thaw period when trucks are not allowed on certain roads. But the road authority needs to maintain the roads to minimize their costs. And this is shown in the next slide. I'm not going to go in great detail here, but the main red line here shows a typical deterioration of a road over its design life if there's no maintenance. If you look at the little scallops of red lines, if you maintain the road, improves the riding quality, deteriorates again, maintain it, deteriorates again, this is what normally should be done. If we don't, we can see what happens down here. So if we spend $1 here on maintenance in this upper region, we save between $6 and $10 down here in the 13, 14 years later. So the maintenance is critical in saving money. And again, if we look at the relationship between the road user costs, which is your freight transport cost basically, and the road network cost, which is the road agency, the red line, if we add those two lines together, We get a low point in the middle, the area of minimum transportation costs. And in terms of road quality, that's where we should be sitting. It's no good spending a lot of money on a very expensive road. We can see the road network costs increase significantly, but we don't want to spend little money and have the high road user costs. We need to be in this optimum area, and this is a function of the road authorities' duties. Okay, to conclude, the freight transport industry depends on road authorities to provide an acceptable route, a statutory obligation in most countries. Climate change is going to make their lives more difficult. Road authorities in most developing countries can hardly maintain, let alone improve roads. Reliance will therefore be on the road freight industry to adapt as much as possible, possibly changing operation characteristics where possible, and start adapting vehicles. Things like suspensions, dust proofing, wading depths, things like this. Interesting challenges ahead for both the road authorities and freight industry. Thank you.